Okay, we're in same house as parent V5, and right now, we're about to do the worklist accumulator. We've got this version of count that doesn't quite work, and it isn't really tail recursive, because there's a mutually recursive call, and there's a self-recursive call, and they're not in tail position, either one. So we got to fix that. What would it mean for them to be in tail position? What would it mean, for example, for this call to be in tail position? Well, it would mean something like this wasn't there, and that like that. Now that call, fun for whiz, oops, and I got to get rid of this one. That call, fun for whiz, is now in tail position. This piece of code doesn't work yet, but it's in tail position. The problem with this piece of code as it is that it'll never go do the rest of the list. But somehow we'd like to call fun for whiz here and have it be in tail position, and still also have the rest of the list of wizards get done. If you look at the picture for a minute, imagine we've gotten all the way down here to when we're doing the children of H, and we're going through this list, and first we call fun for whiz on C, and then rest is the list D. We've got to come back and do those. So what if we just say to fun for whiz, listen, here's the result so far, here's the wizard that I want you to do, oh, and by the way, when you're done doing that wizard, do these two. Now that's a different version of fun for whiz. That's a different version of fun for whiz. It's not the one we have. But if we could make that work, then this call would be in tail position, and it would still get the rest of the list done. So let's try to make that work. Now fun for whiz is going to get another parameter right here, which maybe we'll call to do. And we'll put just a note here for a second. To do is list of wizard, and it's wizards we still need to visit with fun for whiz. It's the ones that aren't done yet. Notice there's a funny relationship between RSF and to do. RSF is every place we've seen, and to do is the things we've been told we should visit, but we haven't visited them yet. Well, what's fun for whiz going to do? Well, fun for whiz is still going to call fun for LOW, but it's got to tell it about to do. It's got to say, listen, you've also got to do these. But fun for LOW already consumes an argument for which the type is list of wizard. It's LOW. It's this argument right here. And it's already going to go do them. All we really need to do is take to do and add the current wizard's children to it. So what this line is saying is it's saying, look, whatever wizards you already knew you had to visit, in other words, to do, add the kids of this current wizard to it, and you have to do them. So we don't really need to add an extra parameter to fun for LOW. It's already consuming a parameter that's a list of wizard that it's going to visit. We could just incorporate this in that. And what we could do at this point is actually we can, just to make this a bit more consistent, I clicked on check syntax, and now I'm going to take this LOW parameter here, and I'm going to rename it to do. And I'll get this stuff out of here. Let's just try it, and then we'll talk about it. Fun for whiz. Oh, I forgot to give this extra argument right here. Well, at the beginning, when you visit the first wizard, there's no pending children that you haven't visited yet, so we'll say empty there. All 6 tests pass. This thing's working. But how is it working? Well, this to-do is another kind of an accumulator. It's a worklist accumulator, so I'm going to move the description of it up to here. And now let's go back to our picture, and let's add the progression of values for this to-do accumulator as we go through. So at the very top, when we come in, we haven't seen any wizards, RSF is 0, and the children that we haven't visited yet is empty. Now, when we go to H, RSF is going to be 1. What's to do? Well, to do is the rest of the children. Let's think about where we go to H from. We go to H from fun for LOW. So we go to H right here. This call to fun for whiz goes to H. First of to do, first of the children of K is H. And rest of the children of K is the list IJ. So when we get back up here to fun for whiz the second time, when we get to H, RSF is 1, and to do is list of I and J. Now we go through the whole thing again. So now we call fun for LOW. Right here, we've called fun for whiz at H. We call fun for LOW by adding the list CD to the front of the list IJ. So when we call fun for LOW right here, I like to say that I'm here by kind of putting a little circle around the lines going to the subnodes. Now I'm at fun for LOW. Well, when I'm at fun for LOW, RSF is 2, and to do is the list CDIJ. I take the first C off of it. I call fun for whiz. Now W is C. To do is the list DIJ, and RSF is still 2. Now what happens? Now what happens is fun for whiz, we're sitting here at C. Fun for whiz calls fun for LOW, and it appends the kids of C. C doesn't have any kids, so that's empty. It appends the kids of C to the front of the list DIJ, so that produces the list DIJ, and it adds 1 to RSF. So now we call fun for LOW down here with these sort of non-existent kids. Fun for LOW takes the first thing off the list. What is it? D. We call fun for whiz with D as the first argument, with the list IJ as the second argument, and with 3 for RSF as the third argument. Notice a very interesting thing happened there. Because we've made this tree traversal tail recursive, it never produces a result until the end. So, in a sense, the traversal of the tree isn't from K to H to C back up to H to D. Or at least from K to H to C back up to the list to D. It's from K to H to C to D, and then to I, and then to J, and then to E. In a tail recursive traversal of an arbitrary arity tree, essentially each node, each wizard calls the next one, and it kind of goes through in a straight line until you get to the end. So here's a question for you. Write down what the real order of traversal is. I gave you the beginning of it. And when you're done with that, imagine that I take the order of arguments to append here, and I change the order of arguments to append like this. Now what's the order of traversal? As we go through here, K, we know it's K, we know it's H next, but then what happens? So that's a little question for you. Take a minute to answer it. Right, so what you saw there is this version here produces what's called depth first traversal of the tree. We go all the way down the leftmost branch to the end before we start going across. And this version produces breadth first traversal. We go across a whole level before we go down. So we do K, and then we do H, I, J, and then we do C, D, E, and on and on. So there we go. That's a tail recursive traversal of an arbitrary arity tree using two accumulators. One accumulator keeps track of the results so far, and the other accumulator keeps track of all the children that we've seen but haven't visited. In other words, everything that showed up in the Wiz-Kids of a wizard we were at, but we haven't yet gone to see them. It's the pending work. And that's why it's often called a worklist accumulator, or I just use the name to do because it's shorter than worklist.